guys, this is going to be objective 22. We're going to continue graphing sine and cosine functions, and we're going to look more at vertical shifts. We already covered vertical shifts. I feel like at the end yesterday you were starting to get vertical shifts, so I feel like we need to do some more of that. So I've got the first couple examples looking at more vertical shifts, and then we're going to talk about phase shifts. Okay? So, basically, I think I'm going to hit the pause button, and I'm going to let you attempt, based on what we did yesterday, to graph this. Okay? I will give you a helpful hint. What did I tell you yesterday that would make your life easier? If we just graphed what? Right. If you just graphed the sine of 2 theta, and then at the end, what's the plus 1 going to happen? What's it going to make it do? It's going to make every point shift up first. So just to kind of get you a helpful hint, just graph the sine of 2 theta. And then at the end of that, take it and shift every point up 1 unit. Okay? So I'm going to hit pause. You try it. All right. So let's see what you came up with. Okay, so I'm just going to make my list over here. I think that sometimes helps us instead of going straight into graphing. So we kind of just make our list. So vertical shift. So what's our amplitude? 1. Okay, so that means we're going to go up 1, down to -1. So far, so good. Okay, what's our period? Okay, it's 2 pi divided by 2, which is just going to be pi. Okay, what does that mean for us? We are going to do 1 full wave to pi, right? From 0 to pi. Okay, and we know our vertical shift is what? 1. And I'm going to put a +1 on here. You need to, when you have a vertical shift, you need to kind of let yourself know, because if you just say 1, that could mean up or down. So you need to make sure you say +1 so we know it's going up 1. Okay? So, cancel. Okay. If I make my list, amplitude, period, vertical shift. What's my amplitude? 3. Okay. What's my period? 4 pi. Do I need to go over how we get 4 pi? Okay, it is 2 pi over 1/2, and when you multiply that, you get 4 pi over 1, which is just 4 pi. Okay, so we're making progress, right? We've got our amplitude, we've got our period, and our vertical shift is +2. And I like how you said +2 and not just 2. Again, if you just say 2, that can mean up 2, down 2. You need to make sure you say +2. If it's moving down 2, then you say -2. Okay? All right, so we're going all the way from 0 to 4 pi. We split it in half, we make 2 pi. We split that piece in half, you get pi. So now we know we're counting by pi's. 1 pi, 2 pi, 3 pi. Let's go ahead and add a couple more points on there. Okay? 5 pi, and then 6 pi. Okay? Just so you can get used to knowing that it's not just one wave and that's the end. Okay? It keeps going wave after wave after wave in the same pattern. Okay? So we know we're going up to 3 and down to -3. Okay? So where's my first point if it's a cosine graph? It's going to be up at 3, right? Okay, then it goes where? Where's the second point? 0, then -3, then 3, then 0, then, okay, and so then you have, and don't forget, remember I said don't make it like a V. I will take off points because it is not a V. This is the most high point. So you got to make sure, because if we kept going, it would come all the way back down and keep waving, right? Okay, keep going. So this is going to come down, then it's going to come back up, then it's going to come down like so, okay? And then it'll go like this. And again, don't extend that bottom point. Go ahead and curve it back up. Okay? Now, that's not our full graph, because then we got to do what? Take your vertical shift, and I'm going to go up 2 more. So this point now goes to 5. This point goes to 2. This point goes to -1. This one goes to 2. This one goes to 5. This one goes to 2. This one goes to -1. And so here is the actual wave itself. Okay? So I think I'm ready to show you how to do this in the calculator. Okay? We're still going to graph by hand. You need to know how to graph by hand. But I'm going to let you, and I don't know if you even want to check them in the calculator, because it's going to be hard to read. The calculator is going to do it by numbers. For example, you know, pi will be where? At 3.14. Do you understand that? So then 2 pi would be where? 6.28, right? So you're going to have to count 6 little marks over and see if, and it's going to be kind of in between. If it's 6.28, it won't be right at 6. It'll be a little bit after 6, and see if it's down -1. Okay? So here's what I will tell you. The reason why you could not put these in your calculator before today was because you have your calculators in degrees. What's our problem in? Radians. So you need to go to your mode, and you need to switch it back to radian. For our trig functions and finding degrees of triangles. Okay, so you need to switch it back to radian, and I want you to go ahead and put in, you can just type right in 3 cosine, and you're going to do, you probably need to do an extra parentheses around 1/2. Does that make sense? Because it's already going to throw a parenthesis to begin with. You probably, so it's going to do something like this. It's going to throw one here, and you're going to do one here, but then you're going to need to throw an extra one around the 1/2, I would venture to say. Okay, go to y equals, yep, you're going to graph it. Throw in, so I'm going to do double parenthesis to begin with. Then I'm going to do 1 divided by 2, close that parenthesis, then do your x. Okay, remember theta is the same thing as x. And then close the parenthesis there, and then put +2. Any questions on how I did that? You may not have, did you close, did you do 2 full sets? Did you do, it gives you 1 parenthesis. Did you do another parenthesis? Then 1 divided by 2. Did you close that parenthesis? X. Huh? No. You gotta do it like this, and then close and hold it all in together. Okay. So when we graph, let me see what I have. Oh, it's there. Can y'all see it? X, it's a variable. All right, so I've pulled up my calculator. I'm going to go, first I need to go to mode, and I've got it in radians, so I'm good. I'm going to clear this out, and I'm going to put in 3 cosine, and again, it throws that first set of parentheses. You need to make sure that's to go around the 1/2 theta, or the 1/2 x. But because it's 1/2, you got to throw an extra parenthesis, okay? If it was a whole number, you could just put 2x. Just 1 set of parentheses. The only reason I have to do an extra parentheses is because it's a fraction, okay? So 1 divided by 2, you got to protect that fraction, so you got to close that. Then I'm going to use my variable button. Again, notice it says xt theta in. It's got the theta on it, but it's going to throw it in as an x. But then you got to throw the final parenthesis around it, okay? And then I'm going to put plus 2, okay? And I'm going to hit graph. And I'm going to look. So we looked at it and we said, you know, we can kind of tell that based on our graph, like when I'm at 0, I am up 5. When I'm at 3.14, which is pi, I'm up 2. And again, I encourage you, I said you could use your trace button. Like if I trace over here to where x is 3.14 or around there, it won't be exact. Like I got 3.19, but look at what the y is. The y is right around 2. Does that make sense? At pi. Now, Amber said you can change your window to fit what you graphed. Like if you want to see it a little bit better, a little more closer up, okay? So if you go to your window, like our window right now, the x is going from negative 10 to positive 10. What did you put yours to? Like, do we want to go all the way to negative 10? I might not start right at 0, like, because that would be right on the edge. I might start at like negative 1. Okay, she did negative 1 to 20. Why did you pick 20? Because on your graph you did 4 pi. What's 4 times pi? 12 something. You see what I'm saying? So like she did all the way to 20 so she could see a little bit past that. So she's going to narrow in on negative 1 and she's going to go to 20. Okay? Then if you go to your y min and max, that's this part. What do you want to go from? What's your lowest point? What's your lowest point on your graph? Negative 1. What's the highest point going to be? 5. So don't put negative 1 to 5 because then it's going to be on the edge. So maybe give it just a little bit underneath. So I'm going to do negative 2 to 6, or you could go negative 3 to 7. And you can graph it and it gives you a little bit more closer up view of it. Okay? If you did your window differently, it is going to look differently. Okay? And again, you can trace down and you can see. You can count over and see. Like I can go look at my negative 1 and I can see, what did we say was at negative 1? What point? What point on our graph, our hand graph, is at negative 1? Levi, what point on your graph is at negative 1? Is it pi, 2 pi, 3 pi, 4 pi? Which one? 2 pi, right? So what is 2 pi? 6.28. So look down here. I used my trace button. I got close to 6.28. I got 6.14, and you can see you're right around negative 1. Okay, you're right around negative 1. So any questions on how to use your calculator to kind of check to see if your points are correct? Okay. So let's try one more, and then we're going to go into phase shifts. This one has purpose, I promise. And I think I'll just leave it here so that I can pull the calculator back up easily. Is that okay? All right, so try this one on your own. This one's a little different. All right, so let's check this out, okay? We know our amplitude is what? 1. We know our period is 2 pi over 5. Ooh, that's yucky. And we know our vertical shift is minus 2. So at the end, we're going to shift everything down 2 units, okay? So we know we're starting at 0. We know we're going to 2 pi over 5, right? We got to get our 5 critical points. So listen carefully. I'm first going to take 2 pi over 5. And I'm going to divide it by 2. I'm going to split it in half. Okay? So, you know, if you're going to use your calculator, you cannot put in the pi because it's going to give you a crazy decimal. So I just put in 2 over 5, divided by 2, math enter, enter, and then on my answer, I put the pi back in. Do you understand that? If that confuses you, you may need to work it by hand, which is not difficult. It's what I did a minute ago. I did 2 pi over 5 divided by 2 over 1, and this becomes what? 2 pi times 1? 2 pi. 5 times 2? 10. And when you reduce that, you get pi over 5. Okay? If you did it in your calculator, you get 2 over 5 divided by 2. Math enter, you're going to get 1/5. And then you go back and put the pi in the numerator. So pi over 5. Okay? How do I get this piece? You do the exact same thing, but don't put in pi over 5. Put in 1 over 5 divided by 2. Justin, tell me what you get. Tankersley. 1 over 5 divided by 2, and then math enter. So really, what's it going to be? Pi over 10. Now, once you get this piece right here, this tells me that I'm counting by what? Pi's over 10. This is 1 pi over 10. This would be 2 pi over 10, which reduces to pi over 5. What's the third one going to be? 3 pi's over 10. Okay, that one doesn't reduce. Well, what's the next one? 4 pi over 10, which reduces to 2 pi over 5. What's the next one? 6 pi over, no, not 4 pi over 10. This one would be 5 pi's over 10, which would just be pi over 2. What's the next one? It would be 6 pi's over 10, which reduces to 3 pi's over 5. You with me on that? That's, once you get this smallest increment, that's what you start counting by. Okay, that's what you start counting by. Okay, so if we did cosine, we know we're going up to 1, down to -1. Okay, where am I starting for cosine? At 1, because that's my amplitude. Then it goes to 0, then it goes to, then it goes to, then it goes to 1, and then here, and then here. So here is your function without the shift. Okay? Then what we're going to do is we're going to shift everything down to units. Okay? Because that's your vertical shift. So this point goes to -1. This is -2. This is going to be -3. This one goes to -2. This one goes to then, and so it's going to go like so. Okay, and you can check it in your calculator and see, and again, you can change. How would you figure out, like, if you wanted to change your window and make it go to 3 pi over 5? What would you have to do? Right, you'd have to take 3 times pi, 3 times 3.14, and divide it by 5. Does that make sense? And that would give you kind of a range for your window. Okay? Any questions on that? Okay, so I want to go to phase shifts. Okay? I want to go to phase shifts. Okay, maybe I'm going to make it bigger so you can see. All right. I want to recall what you did in Algebra 2. So I want you to dig deep in that brain. And we know, like, for example, if I give you y equals the absolute value of x, I always like to go back to that one. We know absolute value graphs are the shape of what? A V. Okay, so there's the parent graph. You with me? If I add 2 on the end of it, it shifts it up 2. Okay? Same idea as what we just did with our vertical shifts. If I subtract 2, it would make it go down 2. Do you remember what makes it go left and right? No, actually multiplying in front of it makes it vertically stretch and makes it vertically compress. Okay? Okay? How did we make it move left and right? Try one more time. that was multiplying it. That makes it stretch and compress. It's actually where you added on the inside of it, like x plus, let's do x plus 3. But I want to see if anybody remembers, because I want you to recall based on what you did. Ah, yay, good. Okay, so we remember. To go up and down, if you add, it makes, up and down makes sense. If you add 2, you go up 2. If you subtract 2, you go down 2. But to go left and right, it's the opposite, because if I did the absolute value of x plus 3, we would think go which direction? To the right 3. It actually goes to the left 3. Okay, it has to do with like zeros, what you plug in, and remember the factors are opposite from the 0, and this is a factor, and I mean there's a lot that it has to do with, but to go left and right, it's going to go backwards. Well, same thing for trig. Okay, we're just applying it to trig functions. So tell me, first of all, if we look at this one, let me clear off my screen. How many kind of sort of remember that from algebra 2? Kind of sort of? How many, like, you never heard of that before in your life? Okay. All right. So just know that. If you're learning it for the first time, just know that if it's going to move left and right, it's going to go opposite from what you think. Okay? So what's our amplitude on this one? Our amplitude is going to be 3. What's our period? It's going to be pi, because it's 2 pi over 2, which is just pi. What's our vertical shift? None. Very good, because that would come out here, right? That would be like a plus 2 on the end of it, or a minus 2. So we have no vertical shifts. Say that one more time. Across. Yeah, you will have some. I'm trying not to, today I tried to give you one or the other. You will have some that you may have to, the amplitude may be different, the period may be different, the vertical shift may happen, and it might have a phase shift too. And there's a little more to the phase shift than what I'm going to show you today, but I'm just going to kind of introduce the phase shift to you, nice and slowly. Okay? So phase shift, and you can actually even think of a phase shift as a horizontal shift. That's what it's doing. A phase shift is a horizontal shift. Okay? What do you think our phase shift is? If it's on the inside, it's going to be a phase shift. Okay? It's pi over 4, right? And I like to put a direction. If this says x minus pi over 4, then we're going to go shift everything pi over 4 to the right. Okay, so I'm going to put a positive pi over 4. That's my phase shift. Okay, now just like we did vertical shifts, until you get the hang of it, we are going to graph just the basic. And then at the very end, I'm going to take every point and shift it where? To the right pi over 4. Do you understand that? Okay, so let's get to work. Here we go. I'm debating on, yeah, if you want to. Yeah, I'll hit pause and let you try it. Okay, here we go. So we know we're going up to 3, mouse closed. 1, 2, 3. 1, 2, 3. Okay. We know that our period is pi. So for this one, you could use the whole method that you normally use. So you go from 0 to pi, then you split it in 2, you get pi over 2, you split that in 2, you get pi over 4, and then that'll be 1 pi over 4, 2 pi's over 4, this will be 3 pi's over 4, okay? And then at the end, we know we're going to shift it to the right, so I probably need to add one more and make it 5 pi over 4. Now, it will not, this one's going to shift to a clear point. right? It won't always do that. Okay, here we go. All right, and so where's our first point? If this is sine, we're at 0, then it goes to 3. Now my question is, are you at the point where you're ready for, so the first point is 0. I think it's still recording, even though it pops. To look at one last one. Okay, one last one. All right, last one. Yeah, last one. All right, here we go. We know our amplitude is what? 5. We know that our period is what? 2. Not 2 pi, just 2. We're just going to cross through that. Here's what I want